This is Rama, JL Botany, and welcome to webinar session 5. Today, we are going to discuss the topic factors affecting enzyme activity. In our previous class, discussed about enzymes, their nomenclature, their classification, and mechanism of enzymes, and different hypotheses on this mechanism of enzymes were discussed in our previous class. And today we are going to discuss the topic factors affecting enzyme activity. These enzymes, they are biological catalysts which are themselves not used in the reactions but increase the rate of reaction. That means here what we have understood is this enzymes, they are made by proteins, and these proteins, they are made by amino acids. That means chain of amino acids makes the proteins, and these proteins, they helps in the manufacturing of enzymes, and these enzymes, they cannot activate, they cannot work themselves. That means their own, they are not active. By adding with another molecules, another non-protein molecules, they becomes functional. So that's what this point is explaining. That means enzymes, they are biological catalysts. Even though they are themselves not used in the reaction, they themselves are not able to participate in the reactions, but they helps in increasing the rate of reaction. Then these enzymes are proteinaceous in nature, which are affected by various factors like external factors and internal factors. And this learning objectives will be to describe the effect of factors like temperature, pH, substrate concentration, and inhibitors on the active sites of the enzymes, which affects the metabolic reaction. So these enzymes, they are considered as proteinaceous in nature. That means they are made by proteins. That we know it very clearly in our previous topics. We discussed this point very clearly. In characteristic features of the enzymes, we discussed at this point that enzymes are made by proteins. All the proteins are not enzymes, but all the enzymes are proteins. That was stated in our first class. By that we can understand these enzymes are made by proteins. That's why they are called as proteinaceous in nature, and this affects the various reactions. And objectives like temperature and pH, hydrogen ion concentration, and substrate molecules concentration, and inhibitors, they they shows much more effect on this enzymes activity. Then before discussing the factors, we have to recall the enzyme catalytic reactions. Now we are going to discuss the factors affecting enzyme activity. Before that, we should recall the enzyme catalytic catalyzing reaction. According to Macallan and Mental, as the enzyme lowers down the activation energy, more substrate molecules reach the transition state, and further they give the end products. As we know that the reaction of enzymes, first substrate molecules, they combines with the enzyme active sites, and because they develops a complex which is called as enzyme substrate complex, and that reaching that enzyme substrate complex state is the transition state. That is the intermediate stage before giving the end products. Definitely this substrate molecules along with the enzymes should reach this point, which is called as transition state. And after that, this transition state leads to give the end products. Along with this end products, enzyme that comes out as it easily. That means enzyme it do not gets any changes during this reaction. Just it helps in enhancing the reaction rate, or it helps in increasing the rate of the reaction, and that comes along with the end products as it is without undergoing any changes. And this point also be discussed. This point is also discussed in characteristic features of enzymes. What is that? The enzymes, they are recycled and reused. One of the point of the characteristic features of enzymes, this was stated. What does that mean? That means enzymes, they starts the reaction with the association of substrate molecules, and by reaching this transition state, they gives the end product. Along with that end product, enzyme also comes out, and this enzyme that comes as it easily along with the end product without undergoing any change. That means it is coming out. That means it is again ready for taking part or to start the reactions along with the substrate molecules. That means it is recycling. That means coming out again and again. It is coming out as an end product, and it is reused for starting of the reaction. Again, it is ready to associate with the substrate molecules. So, as per that point, that means enzymes, they are recycled and reused. So based on that, we can say that this enzyme and substrate molecules together reaches the transition state, and after that they proceeds to give the end product along with the enzyme. So these are the basic enzyme catalyzed reaction equation. That is, and enzyme with the, see here, enzyme by associating with the substrate molecules gives enzyme substrate complex, and furtherly they results in the formation of enzyme with the product. The next, when enzymes combines with the substrate molecules, they togetherly gives enzyme substrate complex, and which that state is temporary. This transition state, it is temporary. That means that there this complex stays for some time only. After that, they proceeds to give the end products, and this complex do not goes back. Yes, this is also one more important point that should be recalled. That is, enzyme under substrate complex, they never goes back in giving substrate and enzyme molecules. Always they shows the forward changes only, forward reaction only, which helps in giving the product and the enzyme as it is, but they never come back in giving substrate and enzyme. So this enzyme and substrate complex, by showing a forward reaction, it dissociates into enzyme and products. So as per Maclais and Mental hypothesis, this complex shows, by showing forward reaction changes, by not showing backward changes, that dissociates into enzyme and a product. So this is about the recapitulation of about enzyme catalyzing pathway. Then this this reactions, that means substrate with enzyme giving complex and finally giving products. This is the process of enzymes, and this process is affected by various factors, and those factors, see here, factors affecting enzyme activity. And this, under this, number of factors affect the activity of enzyme in an enzyme catalyzed reaction. Various factors, they influences the rate of reaction. and majorly affecting the mainly these factors. They shows their effect on the structure of protein and the active sites of the enzyme by showing effect on the structure of protein and showing the effect on active sites of the enzyme. They changes the structure of the whole enzyme. By this protein molecules are changed and enzyme sites, active sites are changed. By that, the reaction will show some change. That's why these factors, especially they shows on the structure of proteins and the active sites of the enzyme. And important factors, what are the factors that influences the rate of reaction? Means the main factors are number one, temperature, number two, hydrogen ion concentration, and third is number three is substrate molecules concentration, and then four is inhibitors. All these are the factors, important factors which shows effect on the enzyme reaction. And let us will discuss about the first factor, that is temperature. Effect of temperature. Effect of temperature. We know that the temperature is most essential factor for all the metabolic activities. And here the enzymes, they are thermolabile. Enzymes are thermolabile. That means very sensitive to this temperature. That means they easily respond to the changes in temperature. So that's why these enzymes are called as thermolabile enzymes, which shows sensitivity to the changing temperature rates. And these enzymes, each and every enzyme has its specific temperature, which is called as optimum temperature. And by having this optimum temperature, they increases up to that temperature. They shows a raise in reaction up to that temperature. So each and every enzyme has its own temperature or has specific temperature. That temperature is called as optimum temperature. And for this enzymes, that optimum temperature is 37 degrees centigrade. And this 37 degrees centigrade of optimum temperature, usually amylase shows this optimum temperature. 37 degrees centigrade is the optimum temperature of amylase. Then next, at the optimum temperature, enzymes works maximum. That means up to this temperature, usually this enzyme shows increasing of the rate of reaction up to 37 degrees centigrade. That is the last peak point of the temperature. Up to that, this enzyme shows increase in rate of the reaction. That's why it is called as optimum temperature. And up to this optimum, that means up to this 37 degrees centigrade, up to this temperature, enzymes always shows increase in rate of the reaction only, and the works their maximum. The next, optimum temperature that ranges from 25 degrees to 40 degrees centigrade. And this is the trend which enzymes follows. That means usually temperature that shows effect on all the metabolic activities, and along with those, these enzymes also, this enzyme rate of reaction of enzymes also be affected by temperature. And for this enzymes, there is a optimum temperature. That optimum temperature is 37 degrees centigrade. And up to reaching up to this temperature, enzymes usually shows increase in their rate of reaction. And optimum temperature usually that is at the peak point of the enzyme's activity. And usually optimum temperature of amylase enzyme. Example for optimum temperature, amylase is the best example, and this amylase enzymes optimum temperature is 37, and optimum temperature also ranges from 25 degrees to 40 degrees. Between this temperature, usually rate of reaction of enzymes that they shows increasing trend, or this is the trend which is shown by enzymes. So under effect of temperature, this enzymes, they are sensible to temperature changes, and each and every enzyme has its own specific temperature, and which is called as optimum temperature. For example, amylase enzyme and its specific optimum temperature is 37 degrees centigrade, and this at this point or up to reaching this optimum temperature, usually enzymes shows increase in the rate of reaction, and optimum temperature ranges from 25 to 40 degrees centigrade. So in this way, enzymes shows their changes according to the temperature variations. The next, at the temperature increase according to the what is Maclin and Menton's hypothesis. They laid the hypothesis like collision theory, and according to this collision theory, more substrate molecules and enzyme molecules, they comes closer with each other. That means substrate molecules, they comes and fit in the active sites of the enzymes. By this, what happens with the substrate molecules, they comes very closer to the enzyme molecules, and when these molecules coming closer, when this happens, this temperature, when the temperature increases slowly, activity of enzyme also increases. When the temperature starts its changing in its activity, gradually enzymes also they increases their effect, and more enzymes or more enzyme molecules can collide with the substrate molecules. They collide with the more substrate molecules, and that means as the temperature increases, or as a temperature shows its change in its status, then according to that, enzyme molecules also starts their change, starts their reaction. What is that reaction? Collide with substrate molecules. That means joining of substrate molecules to the active sites of the enzymes. This change also, this thing also happens, or also starts along with the temperature changes. Then more enzyme molecules, they can collide with more substrate molecules, and joining of this substrate molecules with the enzyme active sites, they reaches the transition state. As we know that the changes of enzymes activity, in that we discussed that substrate and enzyme molecules by joining with one another, they reaches the transition state, which is a temporary state. So here also by the temperature changes, enzymes also starts their reaction rate changing. That means more enzyme molecules they combine with or they collide with the substrate molecules, and reaches the transition state, which in turn they gives end product along with that enzyme also. So this changes, all these changes, they shows all these changes up to certain level only. That means optimum temperature is ranging from 20 to 40 degrees centigrade. So as the temperature increases, as the temperature starts its changes from 20 degrees to 25, then there is a change of 5 degrees centigrade temperature increase. So according to that, this enzyme molecules also starts their variation, or also shows their increase in rate. How means? By colliding with the substrate molecules. So gradually rate of reaction starts increasing, or starts showing increase in the rate of reaction, and reaches the intermediate state, that is transition state, which furtherly undergoes which in turn changes into product molecules and enzyme. And all these changes takes place up to certain level. They shows changes up to a level, that is 20 to 40 degrees centigrade. Up to reaching 40 degrees centigrade, they shows changes. They shows that means more enzyme molecules they participate in the reaction, and more substrate molecules collide with the active sites, and more this enzyme substrate complex molecules are synthesized, and the more end product molecules are produced at the end of this reaction. But after reaching this optimum temperature, which is 40 degrees centigrade, after that crossing that optimum temperature, that means beyond the optimum temperature, if the reactions continues their uh, changes, and how the rate of reaction beyond this optimum temperature. If we observe that beyond the optimum temperature, uh, the temperature that gives a strain, that gives more burden on the bonds of the protein structure. Right. So these two important issues are related with the temperature and its change. The next factor which influences the rate of enzymes is pH. You know the pH, hydrogen ion concentration inside a solution. Here, this pH also shows effect on the rate of reaction or shows effect on the enzymes. The solutions, that means hydrogen ion concentration inside the solutions. Then we know that proteins are made up of, enzymes are made with proteins, and these proteins are made up of various bonds between the amino acids, and those bonds are like hydrogen bonds and disulfide bonds. So, by all the means, what is that? Enzymes are made by proteins, and proteins are made by amino acids, and between the amino acids, bonds are laid, and those bonds are for hydrogen bonds or disulfide bonds. The next, as the pH increases, active sites are changed, and each enzyme has its own optimum pH that ranges from 6 to 7.5. It's same as that of a temperature. Each and every this enzyme has optimum pH, and usually this pH ranges from 6 to 7.5. And enzymes are denatured at extreme pH. That means beyond this optimum pH, if the pH is increased, then enzymes are denatured. And there are extreme pH to some enzymes. That means under extreme pH, also some enzymes are ready to work. And those enzymes are like pepsin. Its pH is 2, which is acidic. And trypsin, its pH is 8.8, which is highly basic. So under these extreme conditions also, these enzymes are ready to work. And maximum enzymes, they works at neutral pH, like amylase at 6.8 and urease at 7 and catalase also at 7. That means all these are neutral pHs. So usually pH enzymatic activity is increased. That shows progress at the optimum temperature. That means 6 to 7.5. But there are some exceptional cases. There are some exceptional cases in which some enzymes, they works under extreme pH also. So majority of the enzymes, they shows they shows their effect, or majority of the enzymes, they works at neutral pH. The next, substrate concentration also shows effect on this enzymatic activity. If the substrate molecules, they are more enzyme molecules are required. If the substrate molecules concentration is more, then automatically more enzyme molecules are required. But there is a point which is called as saturated point. Beyond that, if the substrate molecules, beyond that, if the molecules are more, even the rate of reaction will be influenced. At a constant enzyme concentration, increase in substrate concentration, rate of reaction will be changed. And when the enzyme concentration is constant, substrate concentration is going on increasing, the rate of reaction increases to a certain point. That means here we can see this graph. If you plot a graph between rate of reaction and the substrate concentration, see here the rate of reaction gradually increased when, that means as the substrate concentration is going on increased, and rate of reaction will be increased up to certain point only. See here when the rate of reaction is more, when substrate molecules are more, enzyme is there, when the rate of reaction starts its increase, means when the enzyme active sites all are not occupied by active sites. That means all the active sites of enzyme, when they are not occupied by substrate molecules, then gradually rate of reaction increases, and it happens to a certain point. That means when the enzyme active sites, when the enzymatic active sites, all the active sites of enzyme are occupied by the substrate molecules, then that becomes a saturated point. Then their rate of reaction increases up to that point. That is called saturated point. So here all the when the all the active sites of enzymes are active, so occupied by this substrate of molecules, then only this rate of reaction increases with that change. And after reaching that, this rate of reaction will not be changed. Why? Means all the active sites are filled with substrate molecules. Then by plotting a graph, we can understand the rate of reaction goes on increasing till the time all the active sites are not filled with the substrate molecules. That means after filling all the active sites only, or until unless these sites are filled with the substrate molecules, so that rate of reaction will be changed, or that will be increased. And this that means after occupying all the active sites of enzyme with substrate molecules, they reaches the saturation point. And at this saturation point, all the active sites are filled with the substrate molecules. So the rate of reaction will be more. Then any further increase will not cause any change. That means after reaching this saturated point, if the enzyme molecules are increased, or if the substrate molecules comes and stay there, that will not show any change. That means after reaching saturated point, rate of reaction will not show any change. And at this stage, this is the maximum velocity, or this is called as maximum velocity, or Vmax. Vmax, velocity of maximum. So here what we have to understand is, see here, Vmax. Vmax is the maximum rate of reaction. When this stage comes, means when all the active sites of enzyme, all the active sites of enzymes are filled with substrate molecules, then this stage comes by increasing the rate of reaction. This stage